Okay, so that video was getting really, really long. So this is a separate video that is just for the example of what you're going to do. So hopefully by this point we have made our TUV chart and you are going to watch this in preparation for your 1.2a assignment. So here's an example that goes through all 8 steps. A description, right? This is the same problem we had in the other video. A rectangular field is 100 meters by 50 meters. A man walks the perimeter of his field in 112.2 seconds. At what velocity did he walk? This is what I should see on your paper from these multi-step approach. First, we're going to do a TUV chart. The first thing I come across right here, where's my handy dandy pointer? There it is. Right, is meters, so I put meters. And then I come to seconds, so I put seconds. And then I come to the term velocity, so I wrote velocity. Then I go back and fill in the rest of the chart. But notice what is happening here. Now you're actually filling in numbers and trying to find the actual solution to this. So M is distance, right? X naught is 0 because you can't start from where you're not, right? X is 300. How did we get 300? Well, look at the problem. It's a rectangular field, the perimeter, you walk all the way around, you went 300 meters. And the time is given in the problem, 112.2 seconds. So what is the velocity then? That's the question. So that's a complete TUV chart for this problem. Then we have to do an EWA, equation work answer units. And we are going to talk about that kinematic simple solved for velocity is going to be x minus x naught over t. X being 300, x naught being 0, and time being 112.2. Do the math, you get 2.67, 2 decimal places are generally sufficient, meters per second. So the first thing we had was a written problem, so we did a TUV chart. Then we actually get to solve the problem using our rewrite of kinematic simple for velocity, and we will do those today. Okay, substituting things in, that's called the work, and then you get the answer and the units. Notice I did on the answer put V equals to indicate what I was solving for. Then you need a data table, and this problem is really kind of weird. It would be almost impossible, not completely, but almost impossible for me to make anything other than he started at 0, 0, and he went to 112.2, 300. Okay, so it's got 2 data points in the data table. This would be an XT graph, but notice what's missing. I don't have my axis labels on here. I don't have my title either. So I would lose points, honestly, because I don't have those things on this particular graph. So be sure you have everything on every graph that you need. When you're doing it by hand, it's a whole lot easier than trying to do it on the computer. This is the x equals equation. Literally write the equation of that line. The equation of that line, again using kinematic simple, is x is equal to x naught, which is 0, plus v, which is 2.67, t. That's it. That's the x equals equation. Then you had to do a VT graph and write the V equals equation. Well, a VT graph, since it was a constant velocity, we draw a constant velocity line, a straight line, at 2.67. Okay, notice you do have the time axis down here, match the time axis for the XT graph, And I had a scale, right, counting by 0.5s to get to 2.67, and you just draw a line, 2.67. Then you have to write the equation of that graph. V equals 2.67. That is the equation of that line. Well, that appears to be the end of what we will look at. You will have problems to do today. I did put a sample at the bottom. You also will have video notes. So have a good day.